Black math! Give me some math and I'll give you some flack. Black math!
Let's do 55. Ooh, I like this. Finding probability. Okay, so the probability basically is the likelihood of something happening. Or occurring. Okay, simply put, I was just talking to somebody, I think we've talked about this before, but there's a difference between like what are the odds and what's the probability or the chances. Usually the chances and probability is the same word. So the chance of you getting a heads on a coin is 1/2, right? 50%. So you can give probability in percent, fractions, ratios, or whatever. But odds are like when you say there's a 50-50 chance. That's incorrect. There's 50-50 odds. So 50% for heads, 50% for tails. Or you could say 1-to-1. The odds are 1-to-1. Okay? So when do you guys play that game? What are the odds? Yeah. So I don't even know where to begin with how wrong that is. Okay? But what's the probability? Like what? I don't know. I mean, anyway, it's a fun game. It's gotten me into a lot of trouble. But all right, so likelihood of something happening. Okay. So it is given a number of continuous scale from 0 to 1. So probability is not negative. There's a 0, like you can't get anything besides a heads or a tail. So you can't say what call a hand. I don't know. But there's no hand on a coin, heads or it's just heads or tails, right? So that's a 0 probability. Or you could say, what's the probability of you getting a heads or a tails? Then that is a 1. So you will always get either a heads or a tails. So that's a 1 or 100% probability of that happening. Okay. All right. So they can be written as fractions, decimals, percents. So, for example, you could say P of getting a heads on a coin would be 1/2, 0.5, or 50%, right? So a probability experiment is an occurrence whose outcome is uncertain. Okay, an event is a probability experiment. In a probability experiment can be called a random event because it occurs at random or by chance. For example, the event of getting heads in the experiment of flipping a coin is a random event because it cannot be predicted. Okay, so everything's fair. Like sometimes when you read a probability, you see a fair dice are rolled or whatever. So that means it's not weighted, like Ocean's 11, the weighted die, you know, or the magnets, whatever they put in that. So there's the probability changes when the die is weighted, because it's easier to land on certain sides. It doesn't always land on those sides, but it's easier to land on those sides. Okay, so theoretical probability is different. Now this is something that is new. Theoretical probability. For equally likely outcomes, a theoretical probability P of an event is the ratio of the number of favorable outcomes to the number of outcomes in the sample space. So this isn't new, but the word theoretical is new because this is in theory, but there's a different type of probability that we're going to talk about that is actually taking data and you're finding the probability based on what happened in that data. So that's not what theoretical probability. It's all theoretical. You haven't flipped a single coin yet. All right. There's no data to work with. The only thing you know is how many heads are on a coin and how many possible outcomes you're going to get. Okay. So basically, you could say P equals, and the way they worded it, number of favorable outcomes. It's such a weird thing to say. Basically, number of outcomes of what you're looking for, like heads or something. So this word favorable is weird. But this is just what you're looking for out of the total number of outcomes. This is not new. This is stuff that we've done in Algebra 1 and pre-algebra a little bit, maybe in pre-algebra. But this is officially called theoretical probability. Okay? All right. In theoretical probability, there must be equally likely outcomes. Okay? So it can't be, it's more likely to get a tails than a heads, or a heads than a tails. Okay? Or a weighted die. That is, each outcome has the same probability of occurring. In the experiment of rolling a number cube, it's so much easier to say than die. The likelihood of the 6 outcome is the same as like the 1 or the 2 or the 3. So the probability of even numbers would be 3 because there's 3 even numbers on a die, 2, 4, and 6. So it'd be 3 over 6. So for example, P of even numbers on a die would be 3 out of 6, or just reduced to 1/2 or 50% or 0.5. Okay? All right, so there is another one called geometric probability. Geometric probability is a theoretical probability based on geometric measurements such as length, area, or volume. So this is a probability, but it's still theoretical based on geometric measurements. So what are the odds of you getting a bullseye? Not odds. What's the probability of getting a bullseye on a target?
Well, doesn't that require a stealing?
What's that?
Doesn't that like
Yeah.
who's a professional dart player
Right.
has a higher probability?
So there's some theoretical conditions that I'd have to put to this. But for example, if a dart was thrown randomly onto a target that it was impossible to miss the target completely, then what would the probability be of getting that bullseye? So how would you calculate that?
area.
Yeah, so you find the area.
The area of the whole target, and then find the area of the bullseye.
Yep, so area of bullseye divided by area of whole target. Good. Okay, so that's an example of geometric probability. Same thing, right? You're still looking for number of total, like there's still a number of places inside of that area that you can hit that is still in the bullseye, right? But out of the total target. Does that make sense? So here's the bullseye. Right there. So this would be this area divided by this whole area. Okay? Make sense? Geometric probability, that, I mean, it's the same concept, just with calculating area or perimeter or things like that. Okay? All right, so there's a couple, here's let's just do some examples. Here's example 1, A calculator is programmed to generate random integers, 1 to 100. Inclusive. What does it mean when I say random integers 1 to 100 inclusive? You guys remember?
It's 1.
Yeah, so if I say between 1 and 100, technically it's any number that doesn't include 1 or 100. But if I say between 1 and 100 inclusively, or numbers 1 to 100, I don't think they needed to say inclusive because it says 1 to 100, which is different than between 1 and 100. 1 to 100, where the enter button is pressed. So what is the probability of getting a multiple of 20? Okay, so do you understand the scenario where they had to come up with this weird thing where a calculator just generated a number between 1 and 100 inclusive? So how many numbers are we talking about?
100.
100, right. It's just counting numbers, right? Random integers, 1 to 100. So there's 100 numbers. So we know that's the bottom, right? That's the total number of numbers. So what are multiples of 20? How many multiples of 20 are there? Well, there's 20, 40, 60, 80, and 100. So that would be 5 out of 100, or 1/20th, or 0.05, or 5%. This is nice because this actually gives you the percent, 5%, right? Does that make sense? Okay. So here's 1B. What's the probability that a point chosen randomly inside this figure would be the shaded region? Probability of shaded regions. So here's what this looks like. So how would you calculate this?
Find the area of the shaded region and then find the area of the not shaded region.
So that would give you the odds, right? That would give you the odds if you said shaded versus not shaded.
Oh.
But how do you find the probability?
Of what? You find the area of the shaded part and then the area of the whole thing.
Yep, so you do shade, area of shade, over area of the whole thing. So, well, not the whole thing. What's the whole thing? That's pretty easy, right?
Square. Yeah.
Square, right? So that would be 144 square inches, right? So now how do you find the area of the shaded region?
Find the area of the circle, which is pi times 6.
Yep, so it'd basically be, let's see, if I just kept it in terms of pi, it'd be 144 minus 36 pi all over 144. So I'm going to just put square inches out there. No, you wouldn't do square inches, would you? Because you have square inches on both, and then those would cancel. So its probability doesn't have a label. It's just a fraction. It's just a percent, fraction, or decimal. Okay, does this make sense? You guys remember doing that in pre-algebra? You have to find this shaded region by the whole thing minus that. Well, that's the area of just the shaded region. So the probability of landing on a shaded region at random, which is hard to do randomly, right? But this is theoretical.
If you had a machine that didn't.
Yeah. Then it would be, the area of the shaded region over the area of the whole thing. Geometric probability. It's still theoretical, but it's just a specific branch of theoretical probability. Any questions so far? Okay, awesome. All right, with probability, the hardest part of probability is trying to figure out the total number of outcomes sometimes. Okay, but we already learned that. Those are either permutations or combinations. So how many different outcomes, how many different possibilities are there to line up these numbers or to sit these people at a table or things like that? That's a permutation or a combination. So here's another example. All of the parking spaces in a lot are labeled with 2 different digits. Okay, parking lot. Let's see. 2 different digits so that each parking space is labeled differently. Spaces have 2 different digits. Okay? What is the probability that a parking spot chosen at random is labeled with 2 even digits? Okay, we can do this. So first of all, let's figure out how many different spaces there are. You guys know how to figure that out? You want to do the permutation? So let's not think about numbers because that makes this problem confusing. Okay, so the permutation of how many digits, how many different kinds of digits do we have to choose from? So we have, so yeah, we're going to choose 2. So that's what we're choosing. But we have 10, right? So far, so good. So we're choosing 2 out of a total number of 10 types of digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 0. Don't forget that. Okay. So that's what's going to be the total number. So this is what's going to go on the bottom. Well, can you guys do that in your head? Permutation of, I think you can also do it without this formula, but you could do it with the formula 10 factorial over 8 factorial. But it really, after you choose the first one, you have 10 choices for the first one, right? How many choices do you have for the second one? You have 9 because they have to be different, right? So this would be 10 times 9 on the bottom. Or if I did it this way, it's just 10 factorial over 10 minus 2 factorial. That's a permutation. So this is basically 90, right? If you do this on your calculator, 10 factorial is a really big number. 8 factorial is a really big number, but when you divide those, you get 90. All right, so that's the sample space. That's how many different possibilities there are. Now, how do we figure out where both of the digits are even? How do we do that? Any suggestions? Just wanted to make sure I was recording. I am recording. Any suggestions here? Well, we could just try to go through the list and figure it out if we wanted to. Okay, so listen to this explanation. So the outcomes that make up the event, or the favorable events, are numbers that begin with 0, 2, 4, 6, or 8, right? Okay. And so they have to be even, right? So that if it begins with 0, then it would have to be 2, 4, 6, or 8, right? If it begins with 2, it would have to be 0, 4, 6, or 8, right? So you could do this the same way. You have another permutation. So if you had each of the, so you have an even number, so basically it'd be 5 times 4. So you have a choice of 5 even numbers, right? But you're basically picking 2. So, because they have to be different. So it'd be 5 times 4. So if you have the choice of the first digit is 0, 0, 2, 4, 6, or 8, right? So you have 5 choices for the first digit. And they can't be the same, but they have to both be even. So you only have 4 choices for the next digit because you already used one of them, and they have to be different. So this would be 20 over 90. So your total probability would be 2/9. Okay? All right, so I like this stuff because it's trying to figure out all the combinations and stuff like that. But again, it's not for everybody. I'm going to skip down here. The next example is a set of 22 books, volume 1 through 22, are in a crate. If a student randomly chooses 5 books from the crate, what is the probability that the student picks either the first 5 volumes or the last 5 volumes? Okay. So the total number of outcomes is, so basically you have 22 chosen 5 at a time. So it's 22 factorial over 17 factorial. So that's the permutation, which is about 26,334 different combinations. Okay. But the ones that you're looking for, the first 5 or the last 5, that's just 2. So it's 2 out of that total. Okay. So for events, so here's another, this is something that you already know. We've done this before. These are dependent versus independent events. Okay, so for independent events, remember, do not affect each other. Like when you get a heads 5 times in a row, the chance of you getting a heads the next time does not change just because the coin gets tired of landing on the tails, right? It's still independent. It doesn't affect it at all. For independent events, the probability of A and B, so A and B can be anything, is just probability of A times probability of B. So if you want to say, what's the probability of getting a heads 3 times in a row? So that's A and B and C. So it would be 1/2 times 1/2 times 1/2. Okay. The probability of me selecting a student at random would be 1 out of, how many are you? 7. Okay. 1 out of 7. And then technically if the next one would be different because I have 1 less student, 1 out of 6, 1 out of 5. Okay. So 3 students or something. All right. Now the probability of for dependent events. For A and B. Is, and I'm going to write it like this, and then I'm going to explain it to you. Probability of A times, everything looks the same so far, probability of, let me make sure I write the right symbol here. B, big line, A. Okay, now here's what this means. Probability of B line A is the probability of B given that A has already occurred. So this is the probability of B given that A has already occurred. And just like always, this is confusing. I probably spelled occurred wrong, but I'm okay with that. 2 R's. All right, so let me give you some examples because that's confusing. This is review. We knew that. We've done probability problems for independent events, but this time, this is a probability of dependent events, okay? All right, Avery, are you done with whatever you're doing?
Yeah.
So here's example 3A. Calculator is programmed to generate random integers 1 to 100 inclusively. Okay, so same scenario. When the enter button is pressed, if the enter button is pressed twice, what is the probability of getting a multiple of 20 and then a number greater than 90? Okay, So we want two events happening, okay? So because the occurrence of multiple of 20 on one press does not affect the probability, it doesn't say, oh, you already did multiples of 20, so I'm not going to do that. They're independent events. So probability of multiple of 20, and then comma. So this is two events happening. What's the other one? Greater than 90. Okay. Multiple of 20, what was that? 5 out of 100 times what's greater than 90 inclusively, 91, 92, all the way to 100. So that's 10 out of 100. So then you get 50 out of 10,000, which reduces to 5 out of 1,000, which reduces to 1, 200. Okay, makes sense? These are independent events. You just multiply the probabilities. Okay, let's do one where it's not. Here's example 3B. A bag contains 2 red and 6 blue marbles. We've done these before, right? What is the probability of picking a red marble, keeping it out of the bag, and then picking a blue marble? Okay, so this is a probability of red, then blue. And you are not returning the red marble to the bag. Okay, so what's the first probability? How many reds and how many total? Well, let's see, 2 reds and 6 blues. So 2 out of 8, right? And then what's the probability of getting a blue? 6 out of
7, sorry.
7. That's right. So see how this probability is the probability of that second thing happening if that first thing already happened. So basically it is dependent because now you have one less red marble in the bag. It doesn't matter about the red, it just means you have one less marble. So your chances of getting a blue are a little better because the total number of outcomes has gone down 1. Okay, so that's what these two things are. You've never seen it written like this, but you've done these problems before. Remember what we used to call it in Saxon Algebra 1, we called it with replacement and without replacement. Do you remember doing those problems? Long time ago. Okay, so that's just what this is. That's a dependent event. Okay, well, you can do that math if you want to. So your final probability is, what am I missing? Oh, 2 and 4 can reduce. So you're basically your final problem 3/14. Okay. So, and we already talked about odds of an event. So it's your number of favorable outcomes over your number of unfavorable. And I don't like writing them as a fraction because that's confusing. When I see a fraction, I think of something out of a total. And so if you're writing odds as a fraction, that's confusing. So just write your odds like with a colon because it's a ratio. It's not, I don't like to think of it as a fraction, even though technically it is, but it's not out of a total. So here's an example. A bag contains 2 red and 6 blue marbles. Same scenario. What are the odds of getting a red? 2 reds and 6 blue marbles.
Odds, that'd be 2 and 6.
2 to 6. So you could say 2 and spell out the word 2, T-O, 2 to 6. Okay? Or you could say 2 over 6, which makes me uncomfortable. Or you could say 2:6. Okay? All right? So far, so good? So here's another cool question. The odds in favor of any event, I'm not going to even tell you what it is, are 5 to 2. What's the probability of getting that event? If the odds are 5 to 2, what's the probability of getting that event? 5 over 7, right. So remember, 2 is just what they aren't, so the total would be 7. It's kind of like those ratio problems, and we did the ratio box. You have like girls to boys and then total type of thing. Okay, I'm going to move on unless you guys have questions. A lot of this is strangely familiar, but we're just writing it down a little differently. You guys good? All right, 56. Okay, so we're going to talk about angles of rotation. The hardest thing to remember about this is where you start. Okay, so if you have a graph here, you are always starting here. Start here. So this is 0 degrees. So do you guys remember doing this in geometry? If this is 0 degrees, this is 90 degrees. This is 180. This is 270. This is all the way over back around to 360 or another 0, right? So an angle is said to be in standard position when its vertex is at the origin. So this is like in standard position right here. Okay, so this is going to be somewhere between 180 and 270, right? It looks like it's closer to 180. That might be a 30-degree angle. So maybe that's a 210-degree angle of rotation. Okay, so this is, I think what they said here, it's 205. We'll take it in the book. Okay, when its vertex is at the origin and one ray is on the opposite, okay, got it. The terminal side of the angle is the ray of the angle that is rotated relative to the x-axis. Okay, so this is the terminal side. The initial side of the angle is located directly on the x-axis. Okay, so this is the initial side here. And it's usually just that right side of the x-axis. Okay, an angle formed by rotating the terminal side and keeping the initial side in place is called the angle of rotation. So this is the angle of rotation. That's the measure of the angle of rotation, 205 degrees. Okay, now you could also say this. You could also say that this is also 300 or 155, negative 155 degrees. So I could say, or negative 155 degrees. Okay, so if you go the opposite way, so counterclockwise, which is counterintuitive, is a positive direction, which is hard to grasp because usually we think of clockwise as a positive direction, right? You're going forward in time. But in this case, counterclockwise is positive degrees, but you can go, if it's shorter to get there, go that way. So go this way, a negative 155 degrees. So that positive or negative in the angle just says which direction you're rotating. Okay? Does this make sense so far? All right, so you can write it either way. You can do a negative rotation or a positive rotation. So your examples in your homework are going to be like, okay, draw each of the indicated angles in standard position. Draw 45 degrees in standard position. So roughly, how would you draw this? Well, you need a graph. If you were to guess where to draw this, where would I draw it? I'd start at the origin, right? And how would I draw it? Delaney?
Well, the first one is 90, right?
Yep.
So it'd be midway between them.
Yep, right there. 45 degrees. Boom, done. Okay. Next one says negative 225 degrees. How do you draw that? Any ideas?
It'd be a little bit past the top one, on the right side, right?
A little bit past, like over here?
Oh, wait,
Here, right there.
yeah, right, on
Right
the
there.
left
Yeah,
side.
it would be closer on this side,
Yes.
because this is 180
That's 270.
and this is negative 270.
Yeah.
So it's in between 180 and 270. Let's see there, that's 90. So 90 plus 45 is 235. So it'd probably be a little bit less than that. So like maybe right there. Okay. And that's all you have to do. You don't have to label it or anything. You can just do that. Another way to do this is to convert this to a positive rotation. How do you convert that to a positive rotation?
You just go the other way around, like this way.
Yeah, but what number is this in positive rotation? How do you figure it out?
100 and.
Yeah, how are you figuring it out? You're just subtracting it from 360,
that's
right?
good.
So minus 360 would be what? 135.
Ish, yeah.
Is it? So yeah, that's exactly halfway between. So sorry, I drew that wrong. So 135 is right there. So in between 180 and 270, is that 45 degrees? Yeah, it's 45 degrees more than 180 and 45 degrees less than 270. Okay. Does that make sense? All right, what about this one? 440 degrees. How do you draw that one?
You go all
Just
the
go
way
all the way around
to
this way.
360.
All the way around. And then how much more?
Well, 360 minus 1, or 40, 140.
what is that?
440 minus that.
So is that 80 degrees?
Yes, and then you just add 80 degrees.
Okay, yeah, so you go all the way over 360 and then 80 more to about right there. Or a little bit more than that, but does that make sense? Because you've already done one, you got to take out all your circles. And technically this is the same angle as 80 degrees, okay? Not when you're skateboarding, okay? Because 80 degrees isn't quite as impressive as 440 when you're doing whatever.
You'd fall either way.
You fall.
Yeah, because you have to rotate a multiple of 180, or else you're going to land sideways and fall.
Oh, if you're moving, yeah. But if you're planted and just moving, then. But good point. Safety first. Okay, so there is another term that I'm going to share with you. These are coterminal angles. Now, these are angles that share the terminal side, but the angles 90 and, for example, 90 and 450 or 80 and 440, these are coterminal angles, okay? Because they end up in the same place. So that's just a name that you just need to know. So 440 and 80 degrees are coterminal. Like co-pilot, they share the pilot responsibility, right? Well, these guys share the terminal, the ending location of the angle, okay? So coterminal angles are angles that share the terminal side. Does that make sense? Okay. Now, all that, and you can find these easily. Like here's example 2A and B. Find coterminal angles, angle parentheses of 68 degrees. How do you do that? How do you find a coterminal angle of 68 degrees? How do you find another coterminal angle? There's infinite number, right? But what's the first one?
360.
Just add 360.
360.
Yep. So you get 428. So there's a coterminal angle. You could add another 360. You get 780. 88 degrees. That's another coterminal angle of 68 degrees, right? Because you're just going around the circle again. Okay, good. All right. Now here's the last thing. This is important, and this is what is going to help us with our trigonometry. Okay, and you guys have done this probably in science, but you definitely did it in geometry if you're in geometry. But I shouldn't have erased that. Oh well.
That was a good drawing, by the way. The circles were.
Yeah, thank you.
Yeah.
I like the colors too. I
Yeah.
feel like they made it come alive. Okay, now this is really the only angle that matters. The terminal angles, coterminal angles, yeah, it makes sense. But you need to figure out what the reference angles are. Oh, I said AL. Angles. So a reference angle is the acute angle that's formed by the terminal side of the angle and of the rotation, and the x-axis is called the reference angle. So for example, if this was my terminal angle that landed right here at 120 degrees, my reference angle would be this one. Okay, so this is my reference angle. Oh, I can't use green. Some people can't see green. So first of all, how many degrees is that?
Like 40.
60. How'd you do that?
Yeah.
Because it has to add up to 180, right? So that's 60 degrees. This is my reference angle. Okay, now here's why. Because in trigonometry, we need to build right triangles. Okay, this, you can't build a right triangle out of this angle. You can only build a right triangle inside of a quadrant. So what angle is formed with the terminal side being there? Well, there's two angles. There's technically this 60-degree angle and there's this 30-degree angle. But the reference angle is how it relates to the x-axis. So how far up from the x-axis it goes, or how far down, or how far it rotates down from the x-axis. Okay? So that's the reference angle of a 120-degree angle. Okay? Now here's what I want you to do. And this is usually labeled with a Greek letter. Do you remember what the Greek letter is? We talked about it already in this class. Starts with a TH.
Theta.
Theta. So it looks like an Easter egg. Okay, a little oval, like a zero with a squiggly in the middle. That's theta. Okay? All right, so find the measures of the reference angles for each of the given angles. So here's example 3. Find ref angles for 155 degrees, 240 degrees, and negative 20 degrees. Okay, so now you can so you can graph this if you want, just to make it easier for you to see. But 155 degrees, the way I would figure out 155 degrees is, well, how much from 180? How much before 180 is it? Well, that's, what is that, 25 degrees? So 25 degrees looks like that. So what's my reference angle? 25 degrees. The other way you could have done it is just subtract. 180 minus 155 which you had to do anyway when you had to draw that. You had to kind of subtract and do the math in your head, figure out where to draw it. And this is the cool thing about trigonometry. Just get close. Make sure you're on the right part of the quadrant, but it doesn't have to be exact. It's more for you to visually see how to do your trig, okay? All right, what about 240 degrees? Well, how do you do that? Let's draw it. Where's 240 end up? Well, that's 180 plus another 60. So there's 240. So what's this? Remember, your reference angle is how it relates to the x-axis. So that's another 60. We even said it out loud. 240 is just 180 plus another 60. So you could do here, you could do the same thing. You could subtract it from 180. So 180 minus 240, that's just negative 60. So see how, and the negative doesn't matter. That's just how you're drawing your reference angle. But you just need to do it in the right quadrant and you'll be fine. Okay, what about negative 20? Well, that's easy. That just goes down 20 from the x-axis. So what's your reference angle? 20. That's how far down it goes from the x-axis. Okay, how do you feel about this? Okay, now in trig, technically you could use this as a reference angle and find your x's and y's. Don't get in that habit, okay? You're not going to get stuff wrong, but it might be confusing when you look at your solutions manual and they're doing the reference angle. But you could, so here's the deal. When we start doing polar coordinates and you just got this random point out here, you want to figure out where that is. Like, let's say it goes, and it'll say, I traveled 50 miles at 120 degrees. So that means I've traveled 50 miles at 120 degrees. I want to know my rectangular coordinates. So how far west did I go and how far north did I go? Well, you could do that using trig. Look at this. I could draw a right triangle here. There's my 60-degree angle, and I got my hypotenuse, so I could say like sine of 60 is opposite over 50. Remember, this is 50. Okay. So you could do it that way, and that's like the distance formula as well. So you can either use a Pythagorean theorem, or you can use trig. So here's what it says about trig. So for a point, and we'll call it Q, at x, y, okay, so for example, this could be Q here. So for a point, Q at x, y on the terminal side of theta in standard position, R equals basically this length, so the length of that, R, equals square root of x squared plus y squared. Okay, so if this is your x value and this is your y value, all you did was use the Pythagorean theorem to figure out the hypotenuse. Okay, but also sine of theta is y over r. Cosine of theta is x over r. And then tan of theta is y over x. That's just SOHCAHTOA. So all you're doing to find sine of theta, which is this angle here, opposite of our hypotenuse. Okay, so, and that's something that I probably didn't tell you, sorry. R is the length of that terminal, of that angle. Okay. All right, now, there is one example. I'll just run through it real quick. and then we can be done. So hopefully you'll have enough to do your homework, but a lot of this is just trig that we've already done. But this is our actual application of how we use trig. Okay, so point Q is located on the terminal side of angle theta and has coordinates -5, 12. Okay, so what is the exact value of the 6 trigonometric functions for theta? Okay, so here's what we're doing. -5, 12. So it's about right there. It doesn't have to be exact. Okay, so this triangle here is 5 by 12 triangle, right? So we want to figure out what this is. So do you guys know how to do that?
Kind of.
Actually, and here's the deal. I told you wrong. This is the actual angle of rotation is theta. The way Saxon used to do it is have this be theta, which is fine too. It doesn't matter which one's theta. Either way, you have to find this angle. You could find, so you have to find this angle before you can find this. So you just use your trig. You could say, I'm not going to say it. I'm going to say this is theta. So tan of theta, you could say is 12 over 5. Right? Is opposite over hypotenuse. So what is that? 1.4, 2.4. So tan of theta equals 2.4. Calculator. How do you find theta? If it's if tan of theta is 2.4, how do you find theta? You guys remember?
Isn't it like the inverse of
Yes,
Yeah.
it is. So,
physics?
good. So I'm going to go, so tan and -1, so I'm going to hit second tan of 2.4 equals 67.38. Okay, now here's what I want to do first. I'm gonna do some algebra here. So take the inverse tan of both sides, that cancels that. So theta equals inverse tan of 2.4, which is 67.38, which kind of makes sense. That looks like a 67.38, but I want to know what this angle is. How do you figure out what that angle is?
180 minus.
Yeah.
67.
So it's not all the way to 180. It's 180 minus this theta. So 180 minus 67.38. So even though it's going to give me a negative number, I'm just going to say minus 180 equals negative 112.62. So this equals 112.62 degrees. Okay. So that's how you could do that. It kind of confused things, but the way they asked for it was just in terms of sine, tangent, and cosine. So they just said like 12/13, 5/13, because you could technically use the Pythagorean theorem to figure out what that is. So 5 squared plus 12 squared, take the square root of that, and that'll get you that. But that's it. We're going to do a lot more on these things. Again, not terribly complicated. It's just all these new words and what reference angle is, what angle of rotation is, what coterminal angles are. Don't stress too much about it. Let your solutions manual be your guide in a lot of ways. But then when we take a test on this, I'll make sure you know which ones to remember. Okay? Good job, guys.
Black math, give me some math and I'll give you some flack. Black